So, already discussed. Summarize for me, Eric. What is a series? You have no idea. Were you here 10 minutes ago? Were you listening to me? Give me one key word. If you could give me one key word for the word series, what would you say? Someone help him out. Elena, sum. The sum. When you add up all the terms. Sum. Perfect. Okay? Today we're going to specifically be talking about arithmetic. If you could give me 1 to 2 words to be a synonym for what it means to be arithmetic, what would you say? Bella? Addition. Or Angie? Linear is a great one. I'm thinking of a 2-word phrase that the D variable stands for. Common difference, right? If you see a sequence with +2, +2, +2, and I say that because this is +2, this is +2, you see it? And you can see it right straight through the end, +2, +2. If you needed to, could you fill in the blanks for all those ... dots? Okay, do you have 5 hours on the exam? No, so you're not going to be able to do that. So there has to be a formula. So let me show you this funky little trick. This, by the way, is the only formula they don't give you. I put the sequence, the arithmetic sequence one at the top, but I did not give you the arithmetic series one yet because I'm going to show you how to come up with it because it is one that you are not given. It's the only one you are not given. And the reason you're not given it, I'm guessing, is because it makes a lot of sense, I think, where it comes from. Okay? So let's think about this. If you added your first term with your last term, what would that grand total be? 200, right? First term plus last term, 200. What if you added your second term with your second to last term? Also 200, right? The 3 and the 197. What if you added your third term with the third to last term? 200. Is that a coincidence, or are they all going to be 200? And what would be your explanation? Why does that make sense that they'll all be 200 as you pinch in first and last, second to last, third and third to last, fourth and fourth to last? Perfect. So if you add these two, as you move in on the bottom, you're adding 2, and as you move in on the top, you're subtracting 2, and that adding 2 and subtracting 2 sort of cancels each other out. Exactly. Does that make sense? So then the question is, how many pairs are we going to have? Because we're looking at the list with the middle part of the list just punched out. So it's not like I can just count the terms and divide it in half and figure out how many pairs I'm going to have, right? But I know that the number of pairs that I have times 200 per pair is going to give me my grand total. But how many pairs am I going to have? This is where your arithmetic sequence formula is going to come in. What is your nth term? N being your last number in the term. What is the nth term? What is the last term? 199. So I'm going to write this formula down so I can see what I'm plugging in for what. But the nth term is your last term. That's 199. I don't know what n is. I don't know if 199 is my 7th term or my 70th term. I have no idea what n is, but that's what I'm going to find out. What's a sub 1? Morgan? 1. Again, n is the number of terms in the sequence. I have no idea what that is because they left a whole gap. So I'm going to keep that n minus 1. And what's my d, Lucas B? D stands for common difference. What's that? No. My common difference is what am I adding or subtracting to get from here to here? And from here to here. And then from there to there. 2. So 2 is my common difference. So D is 2. And I'm going to solve for n to find out that 199 is the 70th term or the 80th term or whatever it might be. So I'm going to subtract 1 first to get 198. If I want to, I can distribute the 2 as well. I know that's probably most of your guts, so I'm going to do that. 2n minus 2. Add 2 over, I get 200. Divide by 2, so n equals 100. So if this is my first term, and this is my 100th term, how many terms are in the sequence? 100. So how many pairs then do I have? 50 pairs, right? 100 terms divided in 2 will give me the number of pairs times 200. So that's 50 times 200, and that's 10,000. That's the total if I were to add up all those. Okay? I just added it in a creative way to avoid me having to sit there and pound on my calculator and figure it out because we don't have 5 hours. Okay? But I also did that in a way, as you'll see in a second when I give you the formula, I did it with the way the formula is done. Okay? So here's how the formula works. The number of pairs is going to be given by the number of terms n divided by 2. That's going to give you the number of pairs. And then in parentheses, you want to find out essentially what each pair adds up to. And that's going to come from a sub 1, the first term, plus a sub n, the last term. And that's your series formula for arithmetic series that you have to memorize. It's the only one of that chart up there that's not given to you. Okie doke? Okay, so here's where the maze of formulas carries on. It's very rare to only have to use one formula in a problem. It happens, but in this particular question, I'm essentially, can you tell it's a series question because they're asking you to add them all together? Yes. Can you tell it's arithmetic? Well, if you look quickly at a pattern, minus 3, minus 3. If you look at the end, that's continuing, minus 3, right? So once you classify it as, okay, it's a series, I'm adding everything together, and it's an arithmetic because I have a minus 3 pattern, you steal that series formula, S sub n equals n over 2 times a sub 1 plus a sub n. And I don't know the series total. That's what I'm looking for. I'm trying to add up all those terms. I also don't know n. Do you guys know how many terms are in this sequence? I mean, I see 6 of them, but this dot, dot, dot means there could be 10 more or there could be 50 more. I have no idea. Okay? So I don't know n. The only thing I do know right now is the first term is 20 and the last term is negative 52. Now, I need to find out what n is in order to find out what the series total is. Are you with me? So, to find n, I go back to the sequence formula. So, side by side here, I'm going to pause on the series, and I'm going to search for the n. I don't know n, but I do know a sub n is what, Owen? Nope, a sub n. That means the last term. Negative 52. A sub 1, Angie? 20. Plus n I don't know. And d, Jack B. D stands for common difference. Look at the pattern. What's the common difference getting us? Negative 3. Now, don't just write minus 3, because it's not plus d, it's times d. So it's times a negative 3. Make sure you put that d in parentheses so you remember to multiply it. Let's use that to solve for n so that we can go back to the series formula, which is our main goal, and find the series total. So I'm going to subtract 20 over. At the same time, I'm going to distribute the negative 3. Subtract 3 over, get negative 75 equals negative 3n. Divide by negative 3. The number of terms is 25. So now I can go back to the main point of this problem that I had to pause from for a minute. Now I know that the nth term is 25. Let's plug it in. S sub 25 equals 25 over 2 times 20 plus negative 52. And do that on your calculator. I essentially have 12 and a half pairs. If there's 25 terms, I have 12 and a half pairs. Times negative 32. And just type that in. What is it, Bella? Negative 400. So that notation means the sum of the series through the first 25 terms. So if you take all of these first 25 terms and add them together, negative 400. Just for the sake of reviewing and to make sure we see this side by side and we're not getting confused. What does a sub 25 equal? This has nothing to do with the question. We've already answered the question. I'm past that. I'm just trying to make sure we understand notation. What does a sub 25 equal? What does a sub 25 mean? Okay? The 25th term. And what is the 25th term? Lucas K, help her out. It's negative 52. The 25th term, since this sequence only has 25 terms, the 25th term in this case is the last term, and that last term is negative 52. So a sub 25 being negative 52 versus capital S sub 25 being negative 400 mean two totally different things. The 25th term isolates just what is that term. S sub 25 adds up all of the terms through the 25. Yes? Any questions? Okay. So we mix it up here a little bit. We're given some information, and we're essentially, I was poor with writing directions here, but you have me here to tell you. We're just finding the sum of the series. So the sum of the series, S sub n, just get your formula down. And then we can start to plug in things that we know. And this one's pretty straightforward. So n they're telling us is 13. So S sub 13 equals 13 over 2. So they're telling us there's 13 terms. We are then also told the first term is negative 18 and the last term is negative 102. They're giving you everything you need. Okie doke. Type that in. Get your answer. Does anybody have it yet? Good. Okay? You have to be really careful with these because sometimes if you're doing like problems, you can logically know whether or not an answer makes sense. These numbers get so big so quickly, it's hard to know if that's logical or not. So you just flat out have to be careful with your calculations and what you're plugging in, okay? Okay, the series of, now this one's a little different. It's giving us 10, 12, 14, 16. So can we identify at least that it's arithmetic? Okay, it's kind of a silly question today because everything's going to be arithmetic, but at the end of the chapter, that's not going to be a silly question. You're going to have to identify that first to know what formula to use. So I can see that it's arithmetic, and I can see that they want us to add up the first 11 terms. They did not give me anything else. So if I jump into my formula, did they give us n? What is it? 11. So s sub 11 equals 11 over 2. Did they give us a sub 1? What is it? 10. First term is 10. Did they give us a sub n? The last term is where they lost us. So what do we have to do to get it? We have to go to our sequence formula. So we're going to take a time out here briefly. We're going to go over here. And they didn't give us a sub n. So that's what we're looking for. But we do know that n is 11, right? So we can say that a sub 11 equals, that's the 11th term, equals a sub 1 they gave us as 10. N they gave us as 11. Did they give us the common difference? Sort of. Not on a silver platter, but can you look at the pattern and see plus 2, plus 2, plus 2? I hope so. So the common difference is 2. So if I just crunch those numbers, I now find out that the 11th term is 10 plus 10 times 2. 10 plus 20 is 30. So the 11th term, aka the last term in this particular series problem, is 30. So now I can take that 30 and I can bring it back, use it, and go on with my life. So that's 11 halves times 40, which I think is 220. Is that right? So different pieces of information will be given to you versus missing every time. And when something is missing that you need for the series, go back to your sequence formula, try to find it. Okie doke? So a summation notation problem is giving us, wants us to plug in 1 to 45. Now again, if we don't have 5 hours, we certainly don't have 10 hours because that would take us 10 hours to do. Plug in a 1, plug in a 2, plug in a 3, plug in a 4, plug in a 5, all the way to 45. If you see something that asinine, there's probably a quicker way, okay? So what I will tell you to do is plug in the first couple. If I plug in a 1, what will I get? 3 times 1 minus 9, negative 6. If I plug in a 2, what will I get? If I plug in a 3, what will I get? Do you see a pattern yet? Okay. Put your dot, dot, dot there, and do me a favor and always at least plug in the last term as well. 3 times 45 is 135. Minus 9 puts you at 126. So this is really what we're doing. And if you recognize that the pattern is plus 3, plus 3, plus 3, you know, hey, that's arithmetic. Hey, it's asking me to add them all together. Wow, it's an arithmetic series, right? Good? So jump to your formula. S sub n equals n over 2, a sub 1 plus a sub n. And here's where the question is going to come up. How many terms are there from 1 to 45? 46. No. Who said 46? Take it back. How many terms? 45 terms, right? That's what we talked about at the beginning of the class. The difference between those is 44, and then add on one more, right? It's easier when it starts at 1, I think, but it's really when it's like from 8 to 20 that it becomes a little bit tricky. but 1 to 45 is 45 terms. So S sub 45 equals 45 over 2. The first term was negative 6. The last term was 126. And there's your answer. Crunch those numbers, you have your answer. Now, for safety reasons, that's the way I do want you to do it. You know, if I take the top 25% of you, what could you notice about this? The series part is obvious, I think, because a summation is a series. What about this makes you know it's arithmetic? That's a linear format, right? Isn't that the mx plus b format? So if you see that, that's also, without actually doing this, you can probably use that arithmetic series formula. But nonetheless, you'll probably still need to come up with the first term and last term. So you might just want to do that just to be sure. The common difference comes from the slope. Yes? So if you're ever looking for a shortcut, but I don't want you to use a shortcut unless you really fully feel like you got it. Jason's going to hand out a homework sheet to everybody, and I'm going to pass out your trig tests. Corrections for your trig tests will be due on Thursday. Any questions?